So we've all been told the same thing, right? The future of software is all about writing that one perfect prompt. But, anyone who's actually tried to build a real-world project with AI knows that's a complete dead end. Today, we're going to move way beyond just writing simple prompts. We're going to explore a much more powerful way to build with AI, which you might call true systems engineering.
And this quote, man, this just captures that moment perfectly. It's the moment every single developer hits, I think. That initial wow factor, the magic of AI, it's worn off. And now? Now we're stuck dealing with the consequences. All the messy, completely unmaintainable systems that it so often spits out.
Okay, so let's get into it. The core issue with most of these AI assistants really is what we can call the glorified autocompleter problem. Look, they're fantastic at small, isolated things, like writing a single function. But the moment you ask them to build a whole, coherent system from the ground up, they completely fall apart.
And this leads to a whole new kind of headache, something we're calling generative technical debt. This isn't just about a simple syntax error. No. This is high-speed spaghetti code, churned out by an AI that literally has no memory of what it did 5 minutes ago and absolutely zero long-term vision for the architecture. It's a total mess. And I bet the symptoms here are going to sound painfully familiar to you. You've got architectural amnesia, right? That's when the AI forgets the database schema it literally just designed 3 prompts ago. It'll mix libraries that have no business being together, completely ignore your environment variables and network topology. Basically, it acts like this hyperactive junior programmer who's just desperate to start coding right now, without any kind of plan. So the big question is, why? Why does this keep happening? Well, the answer actually lies in this really fundamental conflict that's going on deep inside the AI's neural network. It's a concept we can call its internal paradogma.
In this comparison here, it just breaks down that internal conflict perfectly. Okay, so on one side, you've got the paradigm. Think of this as the brilliant child. It's been pre-trained on basically the entire internet, all of GitHub, all of the textbooks. It genuinely understands logic, algorithms, complex architecture, but on the other side, you've got the dogma. This is the angry teacher, and this is that RLHF layer, reinforcement learning from human feedback that's been conditioned to punish the AI anytime it gets too proactive or assertive. It forces the AI into these super cautious, evasive, almost moralistic responses.
Now, the crucial thing to get here is that this isn't just some clever metaphor. It has a real technical name, the alignment tax. That's right. The very process that was designed to make AI safe and aligned has, it's effectively neutered its ability to execute complex technical tasks on its own. It's been trained to stop and ask for permission, not to actually go and build an entire system.
Okay, so once you really understand this internal struggle, everything changes. Your whole strategy has to shift. We have to stop trying to persuade the AI with clever prompts and start engineering a system to actually control it. And that begins with picking the right kind of model for the job.
You can really think of AI models as falling into 2 main camps. First, you've got your conversational models. These are the trained dogs. They're terrified of making a mistake. They're constantly seeking your validation. They make for a great consultant, but they are a terrible, terrible executor. And then you have the agentic models. These are the racehorses. Their one and only goal is ruthless task completion. They take initiative without asking, and all they care about is getting to exit code 0, no matter what it takes.
But here's the huge catch, right? That's a double-edged sword. If you just let that racehorse run wild without a track to guide it, you're just asking for a catastrophe. An unleashed agentic AI will create an absolute Frankenstein's monster of code. I'm talking hard-coded passwords, mixed-up libraries that don't work together, all in a blind rush to just finish the task. Because speed without direction, that's just an accelerated disaster.
All right, so if we can't let the racehorse run free, how in the world do we harness all that power? Well, this is where something called the JSON Voorhees method comes into play. And it's a really fascinating, totally counterintuitive solution. It turns out to get reliable, powerful results, you have to impose extreme, almost brutal restrictions on the AI.
And this slide, right here, illustrates the core of the whole method. Instead of having a conversation, you literally force the AI through this super rigid 6-step pipeline. And each step is defined by a JSON file. This whole pipeline basically acts as an external, persistent brain for the AI. It's not allowed to move on to the next step until the current one is completely finalized. This creates an unbreakable chain of architectural logic.
Now, the single most crucial piece of this entire system is this one little line of code. From the very, very beginning, a master file sets can_execute code to false. What does that mean? It means the AI is physically forbidden from writing a single line of source code until the entire architecture is planned, defined, and locked down in those JSON files. You're forcing it to think before it acts. Which, of course, brings us to that pretty memorable name. The developer who came up with this has a bit of a dark sense of humor. They explain it like this. That set of 6 JSON files, that's the machete. It's ruthlessly cutting down any attempt by the AI to write unplanned, sloppy code. It completely annihilates that generative technical debt before it's even born.
Okay, so this all sounds fantastic in theory, right? But does it actually work in practice? Let's get to the proof. We're going to see how this method performs in a deliberately hostile environment, an environment that was specifically designed to make it fail.
And we are not talking about your average to-do list app here. The NARP stack was chosen as the ultimate stress test for a reason. You've got Rust, whose compiler is famously unforgiving. It shows zero mercy for bad code. Then you're orchestrating the whole thing in Docker, which creates massive networking complexities. This entire stack is designed so that even the slightest lack of precision will cause a complete, catastrophic failure. So, the moment of truth. The JSON plan is locked in, the code lockdown is finally lifted, and the AI gets the green light. It issues its very first command to build the whole system from scratch. And, just as you'd expect, it immediately hits a brick wall.
But this is where things get really interesting. The build fails. There's a fatal compilation error. Now, a normal AI would just give up and ask you for help, but not this one. It actually reads its own error log, it diagnoses the problem all by itself, and then it announces its plan to fix it. And then it just does it. Without a single bit of human intervention, the AI goes, opens the Docker file, patches the base Rust image to the newer version it needs, and just retries the build. It's literally debugging its own configuration on the fly. It's incredible. And this wasn't just some one-off fluke either. You look at the logs, and you see it happening over and over again. The AI gets into a full-on brawl with Rust's infamous borrow checker, and then refactors its own code to make the compiler happy. It even goes so far as to test its own live endpoints with curl, discovers a CORS error, and then autonomously patches the middleware to fix it. What you're seeing is a repeatable, self-healing loop in action. So let's step back for a second. What does a system like this really mean for the future of our jobs as developers? I think it points to a really fundamental and, honestly, a very exciting shift in our role in this new age of AI.
Look, let's just be blunt. The whole idea of prompt engineering, this fantasy of becoming an expert at writing clever sentences, it's a dead end. It just doesn't scale. The real durable skill moving forward isn't about persuading an AI. It's about designing the robust, unbreakable boundaries that force it to produce quality work. The future belongs to the systems engineer.
And this quote just nails the new relationship perfectly. The AI can be our hyperactive, tireless bricklayer. It can execute the grunt work at a speed we can't even imagine. But we, the humans, we get to level up. We transition into the role of the master builder, the architect who designs the entire system, defines the contracts, and ultimately signs off on the final blueprints.
And that really leaves us with a provocative question we have to ask ourselves about our own work. As these tools continue to evolve at this insane pace, we all have a choice to make. Are you going to spend your time just building prompts? Or are you going to level up and start building systems?